Hey guys, meteorologist Jim Rinaldi here. We're taking a look at winter weather forecasting once again. This time we're going to go more with what to look for in different charts, what to look for as far as thickness values goes. And I mentioned yesterday the magic number. I'll show you what that is in a second. And these are just general basic guidelines. Nothing in meteorology is ever written completely in stone. There are always variables that you have to consider with each individual forecast. But one thing I wanted to stress on here is that, you know, the 540 line, the 0850 line are not the be all end all of where it's going to rain and where it's going to snow. And so, you know, you want to look at a lot of different factors when determining precipitation type and determining where heavy snowfall is likely to be occurring. So, but first, you have to know what's going on. So it's always important to look at the current observations, look at the current maps, weather surface maps, look at the current satellite, water vapor, all that type of stuff. And then what you want to do is you want to look at the individual models' initialization and see where the models are placing the low pressure. If the models are, you know, all pretty much in agreement, well, then you can go by whatever the model biases are. But if you have a model that has a low pressure system about, 100 miles away from where it actually is at initialization, well, then you can pretty much know that that model is going to be garbage because it's starting out at a bad point. So how can you trust it going forward? So that's something to look at there. But and then there's also, I have here, you can see the page to go to for model biases. And see what some of the more common ones are. But as far as precipitation type goes, of course, everybody looks at the 1,500 thickness and the 850 temperature. For those that don't know, thickness is the difference between one height level and another. And the greater that difference is, the warmer it is. So now 1,500 is indeed a good starting point, but the mid and low level thicknesses are going to be just as, if not more, crucial to determining snowfall or precipitation type. And these are the critical thicknesses for the various levels. So from 1,000 to 850 millibars, you want a thickness of 1310 or lower. Now, again, this is location dependent. For example, here in State College, it's more like 1312, because we're at a higher elevation. So it's, but in general, these are good guidelines here. 1,700 thickness, you want to be about 2860 or lower. Of course, 1,500 is 5,400 or lower. And then you have the 850 to 700 millibar thickness, and you want that to be around 1,560. So that's what you're looking for in these different thicknesses. Now, the magic number is you take 2 times the 1,850 millibar thickness, add to that the 850 to 700 millibar thickness, and a critical value of 4,180 comes out. Now, the reason this is important, and it stresses also the importance of the lower level and mid-level thicknesses for snowfall events, because it really weights those heavy. In fact, you can see it doesn't have the 1,500 thickness in there at all. So, it's showing you that, most snow is starting to fall below the 500 millibar level. So, and you can see here, most snow does form and fall below 600 millibars, actually. So, so for example, you can have 1,500 millibar thickness that's above, 540 and still have snow because the lower levels where the snow is actually occurring is going to be within critical value. Now, if for those of you that don't know, I have an Excel sheet I use when I'm doing snowfall forecast. And what you do with this is, you put whatever site you want to use, UNV, whatever, and then, the NAM. Now, it's not going to pull this stuff up for you, but what you'd have to do is go to the models and find the height levels for each of these millibar levels and plug those in. And then it's going to give you, what type of precipitation to expect. It's going to calculate the different thicknesses for you. It's going to calculate the magic number, and it's going to then predict what type of precipitation you'll be getting. So anybody wants that, let me know. Email is wxjim@comcast.net. Send that to me, and I'll get the program out to you for you to use if you'd like. Now, as far as precipitation type and precipitation strength, storm track is vital to that. And if you're along the coast, you don't want the storm riding right up the coast. If you're a coastie, you don't want to see that happen, because the closer to the coast, the more warm air is going to get pulled into the storm system. So you don't want to be seeing anything like that. Also, it's ideal if you have high pressure building into the north. You don't want to see an exiting high to the north. You want to see a fresh cold air mass coming into the north. Now, it's certainly you can still get snow without that. It's possible, depending on how much the storm is wrapped up or whatever. But in general, you want to see that high pressure system moving in. Now, for the newer people coming in, we're going to talk about a couple of things here. We're going to talk about vorticity. Vorticity is basically the amount of upward motion in the atmosphere. Vorticity maxima, or vortmax, is the center of highest value. And most common maps is donated by an X at the 500 millibar level. Isotherms, talking about isotherms, they're lines of equal temperature. Iso means equal, of course. And now, for heavy snow, if you're looking for a forecast for heavy snow, and you have the right storm track, and you have cold, all the thicknesses are in the right levels, here are the things you want to look for heavy snow. One, you want a 500 millibar vorticity of at least plus 14 to plus 19 for ideal. You want a 500 millibar temperature within 3 degrees of latitude of this storm to be between 37 below and 24 below zero. And heavy snow is generally going to be found about 7 degrees to the east and 3 degrees to the north of the vort max. So you want to be looking for that. Look for this. I'm going to show you this on the 93 Superstorm. But look for the 1,500 millibar thickness ridge and the 1,700 millibar thickness ridge, which that I don't have available right now, but I do have the 500, so I'll show you that. And normally heavy snow occurs around the 850 millibar -5 line. Actually, it's more like -5 to -8 is going to be your corridor for heaviest snow. And in most cases, there are exceptions, of course. And also within about 60 to 90 miles to the left of the track of the 850 millibar low. So let's take a look now at the Superstorm, and I'll show you what I'm talking about here. Okay, the first one was you want a vorticity of between -14 or plus 14 and plus 19. Well, okay, that's not really going to be a problem here, because you can see we're up in the plus 30 to plus 34 range here. So obviously that is not an issue with this particular storm. So that certainly is not a problem. Now the next one was you want to look for the 1,500 thickness ridge, and you can clearly see where that is in here. Okay, so that's that's very evident as to where that thickness ridge is. So you want to be looking for, obviously you want to be in the colder air here, so you want to be back here. So we're looking, in this zone here is where we want to start concentrating on the potential for heavy snow. Another one was you want to be just double check those numbers. I have so many in my head right now. You want to be 7 degrees east and 3 degrees north of the vortmax. So here is your So here's your vortmax coming up. So you want to be, it's going to be rotating back like that. So again, you want to be coming up, somewhere. Again, you're focusing somewhere in this area here for your heavier snow. You want to look for the 850 millibar about -5. Well, this is now this storm was a bit of an exception because it pulled so much cold air into it. So you actually had heavier snow at a lower temperature here. But like I said, normally it's between -5 and -8. Certainly. It obviously in this case it was like -10 and it was still heavy snow behind it, so that this was kind of an exception to the rule. But like I said, there are always exceptions, and you have to look at each storm individually. It's not as easy as making a cake goes. But again, you're looking in there, and you also want to look at the 850 millibar low track. Like I said, it's going to be about 90 miles, 60 to 90 miles to the west of that is going to be your band of heaviest snow. So here's your 850 millibar low. You can see based on the the flow here that you're probably going to get a low tracking up like that. Go about 90 miles west of there, and you're looking in this zone here for your heaviest snow. And here is the snowfall verification. And indeed, that is exactly where the heaviest snow fell with that storm. So those methods do work and in general, and but like I said, you have to look at everything on an individual basis. And so something also to look for that's very important is if you have a zone of high 700 millibar vertical velocities intersecting the -5 to -8 corridor at 850, of course in the presence of moisture and a storm and such, that is going to be a place to look for a nice convective band of snow to be setting up. So if you're looking to nail an area that's susceptible to a heavier snow band, that's something to look for. Look for where that 750 or 700 millibar vertical velocity intersects with the -5 to -8 corridor, and it's a very good tool for forecasting heavier snow. So those are some basic things as far as how much snow falls. QPF is something to look at. Now, one thing I want to stress is that QPF is probably the least accurate of all the model parameters. So you don't want to take it verbatim, and you also have to take into consideration what the situation is. In other words, 10-to-1 is the basic first guess. But if you have a situation like Superstorm 93 where you have temperatures in the teens with dew points in the teens, well, then you're going to get 20-to-1, maybe even 25-to-1, or a lake effect event could be something like that. If you have a 32-degree temperature, 32-degree dew point, it's going to be more like 5-to-1 with a lot of possible sleet mixing in and things like that. So there's a lot of things to consider. All the guidelines are just that. They're guidelines. They're not set in stone. So look at each individual situation and determine what the most likely outcome is. So those are some very basic things I wanted to go through as far as predicting snowfall, predicting precipitation type. Let me know if you need that spreadsheet. I'll get that out to you. And Josh is going to be doing a write-up on using the SKU-T to see all this stuff. As far as particularly you can determine thicknesses and warm layers and things of that nature through that. And but I just wanted to give you a rundown of the models and how to look at different things. So that is it. I hope that's been helpful. I am meteorologist Jim Rinaldi. We'll have more for you later.